All right, Chapter 4, Section 8, complex numbers in the complex number system. This is basically a system that exists only when you have real numbers and imaginary numbers together, okay? It's when you have two numbers that you cannot combine, kind of like terms, and we call it a complex number. So the first number is always the real number, the second number is always the imaginary number. We call the combination of the two a complex number. So you might have 4 minus 2i. We talked about imaginary numbers yesterday, so now we're just combining the two. How do you graph complex numbers? Well, the graph looks the same. The only difference is we use the x-axis as our real number and the y-axis as our imaginary number. So what we're going to do is we're going to go and graph these. I have 3 plus 4i. 3 is my real number, so I go right 3 plus 4i. I'm going to go up 4, and I have 3 plus 4i. 3 minus 4i, still going right 3, but now I'm going down 4. Negative 2 plus 2i. Negative 2 is my x-axis, going back 2, plus 2, up 2. So I have negative 2 plus 2i. And finally, negative 2 minus 5i, negative 2, down 5. 1, 2, 3, 4, 5. Adding complex numbers. When we add complex numbers, all we're doing is combining like terms. So when you have two complex numbers with addition in the middle, I'm just going to go ahead and add. I don't have anything to distribute or combine inside the parentheses. So I have 9 plus 23, which gives me 32. And I have 7i minus 21i, which gives me negative 14i. I cannot combine these two. This is my final solution. When you're subtracting complex numbers, you want to do the same thing. The only difference is I want to go ahead and distribute that negative sign before I combine like terms. So this becomes 6 plus 9i minus 12 plus 13i. Now when I combine like terms, I have 6 minus 12, which gives me negative 6. I have 9i plus 13i, which gives me 22i. When we're multiplying with complex numbers, we're using the same strategies, same algebra strategies, only one thing changes. Because when we distribute this, 3i times 4 gives me 12i. 3i times negative 7i is negative 21i squared. And if you remember back to the first set of notes that we did, imaginary numbers, when you have I, that just gives me the square root of negative 1. However, I squared gives me the square root of negative 1 squared. My square root and squared cancel out, so I squared is actually just negative 1, and if you remember, that is just a real number. So when I have this I squared here, I'm going to change this to negative 1, and then I have 12i minus 21 times negative 1. 21 times negative 1 is, or negative 21 times negative 1 is positive 21, so it changes. Now, the solution is correct, however, it's written in the wrong order. Remember, a complex number, the real number always comes first, the imaginary number comes second. So I want 21 plus 12i so that it's written in the correct order. Now, when you're foiling complex numbers, you're going to do the same thing. The biggest thing you need to remember, you can only combine like terms, and that I squared is actually negative 1. So when I FOIL this, 4 times 3 is 12. 4 times negative 7i is negative 28i. 3i times 3 is 9i. And 3i times negative 7i is negative 21i squared. Combine like terms and change your I squared to negative 1. So this gives me 12. Negative 28 plus 9 is negative 19i minus, or actually this is going to become plus 21 because negative 1 times negative 21 becomes a positive. Combine your like terms, gives me 33 minus 19i. Next, another FOIL problem. Go ahead and FOIL. So I have negative 3. Negative 3 times 4i is minus 12i. Negative 15i times 1 is negative 15i. Negative 15i times 4i is negative 60i squared. Combine like terms. and change your I squared to -1. -3 minus 27I plus 60. -1 times -60 makes it a positive. Combine your like terms. So I have 57 minus 27I. Final answer. Now, something that you have to remember when you're dividing, so far we've added, subtracted, multiplied. Now we're going to go ahead and divide complex numbers or imaginary numbers. You cannot have an imaginary number, an I or a square root in the denominator. So when you solve these, you need to use some strategies to get rid of the I in the denominator. Denominators may not contain radical expressions or imaginary numbers. Multiply by what you need to eliminate the radical expression or the imaginary number in the denominator. Remember, I squared is -1. When you multiply by 1, it doesn't change anything. However, 1 can take a lot of different forms. For example, 2 divided by 2 is actually 1. X plus 2 divided by x plus 2 simplifies and it's 1. I over I is also 1. So we can manipulate 1 to be a lot of different things. Okay, so we're going to go ahead and do that when we're dividing imaginary numbers to get rid of the I in the denominator. So when you're solving a problem like this, I have an I in the denominator. So to get rid of the I in the denominator, I have to multiply by 1. But I'm going to manipulate that 1 so that I can multiply the bottom and make the bottom I squared so that there is no longer an I in the denominator. So I'm going to make that I over I, because I divided by I is 1. So I have 9 plus 12I over 3I times I over I. When you multiply fractions, it's exactly, you just multiply the tops and multiply the bottoms. Multiply the numerator times the numerator, the denominator times the denominator. So I have 9 plus 12I times I, distribute. So I have 9I plus 12I squared over 3I times I is just 3I squared. Now, change your I squareds to -1. So I get 9I minus 12 over -3. Distribute your -3. I have 9 divided by -3 is -3I. -12 divided by -3 is +4. Change the order so that it's in the correct order of a complex number. Now, same thing with this one. Multiply by I over I. Distribute your I on top. So I have 5I. 5I minus 2I squared over 3I squared. Change your I squareds. Page 2. Change your I squared to -1. So I have 5I plus 2 over -3. Distribute it, so I have -5/3 I minus 2/3, and then change the order so it's in complex form. Now, when you are dividing by an actual complex number and not just I, you have to multiply by 1 still, but we're going to multiply then by the conjugate of the denominator. Now, what the heck is that? Dividing by a conjugate. A conjugate is just where you have your complex number, the real number stays the same, but you're going to change the sign of your imaginary number. So if I have a plus bi, the conjugate of that is just a minus bi. Real number stays the same, change the sign of your imaginary number. Negative a minus bi becomes negative a plus bi. Change the sign of change the middle sign, or the sign of the imaginary number. So if you look at this example, 5 minus 2i divided by 3 plus 4i, I have to divide by the conjugate of the denominator. Let me say that again. Divide by the conjugate of the denominator. Or multiply by the conjugate of the denominator. So I have 3 minus 4i over 3 minus 4i. FOIL the top, FOIL the bottom. 5 times 3 is 15. 5 times negative 4i is negative 20i. Negative 2i times 3 is negative 6i. Negative 2i times negative 4i is 8i squared. Over on the bottom, I have 3 times 3, which is 9. 3 times negative 4 is negative 12i. 4i times 3 is 12i minus 16i squared. Change your I squareds and combine your like terms. So this becomes negative 1, like terms. So rewrite it. I have 15 minus 26i minus 8 over 9. These cancel, plus 16. Notice how my I, or my imaginary number, is now eliminated from the denominator, which is what I wanted. So combine like terms on the top. 15 minus 8 on the top is just, did I change the sign of that? Yeah, I did. 15 minus 8 is 7. So 7 minus 26i over 25. Distribute, and then change the order. So I have 7 over 25 minus 26 over 25. Actually, no, it's in the correct order. Let's try it again. Oh no, and that's it.